Hello students, welcome to Sri Chandra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of a unit waves. So let's begin with today's class. In today's class we are going to discuss about the principle of superposition. So let's begin. A principle of superposition of waves states that when two or more waves are simultaneously impressed on the particle of the medium, the resultant displacement of any particle is equal to the vector sum of the displacement of the waves. As you can see that there are almost three waves are there and which are moving or which are propagating in the same direction. Two are in the same direction and one in the opposite direction. That means any particle of the medium is facing three waves simultaneously, then the displacement of any of the particle of this medium is basically the vector sum. This is what we understood by the superposition. Let's take an example that we are having y1, y2, y3, etc. are the displacements of the individual waves due to superposition. Then the resultant displacement at any point of superposition can be given as this: y is equals to y1 plus y2 plus y3 up to yn. And the principle of superposition, it will hold good for all types of waves. I hope this is clear. And one very important point is, after crossing point of superposition, the individual displacements of the wave remains the same always. Please do remember this. I hope this is clear. Is it clear? Is it? Great. So do you understand this? Yes. Let's see certain mathematical treatment of the same. So basically when we say that it's a superposition, let's suppose I am having one wave. It's a sine omega t minus of kx, and I am having the another way which says it's a minus a sine omega t minus of kx plus phi. So if I want a superposition of this two, it's a y1 plus y2, then I will get something that is AR. It's a resulting amplitude of the superposed wave, sine omega t minus of kx plus phi dash. Phi dash, what I want that it's a new angle. That's it. Now how to find out the AR? As we have said that it is the vector addition. Let's say this is the first, this is the second, and this would be the vector addition of this two. So if it is the vector addition of this two, look at this, its amplitude is a, its amplitude is a, so both are having the same amplitude. Next, what is the phase difference between this two? A phase difference between this two, it's an omega t minus of kx plus phi minus of omega t minus of kx. When I solve this, I will find it's a delta phi. It's a phase difference which is equals to phi. So amplitude is same and phase difference is phi, so that resulting amplitude of this waves could be solved by this relation. It's a 2a cos phi by 2. So this resulting wave could be calculated as 2a cos phi by 2 into sine of omega t minus of kx plus phi dash. I hope this is clear. This is the resulting amplitude. I hope this is clear. Is it? So please noted it. Please noted it down that this will be the resulting amplitude. I hope this is clear. Is it clear? Is it? Are you sure? Great. So ready for the question? Let's have a look. Let's suppose the question is that y1 is equals to 3 sine omega t minus of kx. The another is the 3 sine omega t minus of kx plus 60 degree. If these two waves are superposed if these two waves are superposed, find out amplitude of resulting wave. This is the requirement. How will you do this? How will you do this? That if these two waves are superposed, we need to find out. We need to find out the amplitude of resulting wave. So this is the amplitude, this is the amplitude, and we need to superpose these waves, and we need to find out the amplitude. Yes, both are having the same amplitude, and this is the phase difference between them is the 60 degree. It's a omega t minus kx, it's a omega t minus kx plus phi. So the resulting amplitude could be written as it is 2 into a into cos phi by 2. So this is equals to 2 into 3 into cos phi by 2. It's a cos 30 degree. So this is 2 into 3 into cos 30. It's a root 3 by 2. So this has gone, and this will give me a 3 root 3 units. I hope this is clear. Is it? Is it clear? Are you sure? Great. So this is the situation. This is the situation if two waves are having same amplitude. But let's suppose understood that if two waves are having different amplitudes and the phase difference between them, is, let's say, phi, then resulting amplitude of wave can be calculated as, so the resulting amplitude could be given as, this is AR would be equals to root of A1 square plus A2 square plus 2A1 A2 cos phi. Yes, this is the same as we have done it for the resulting vector, the value to find out the resulting vectors. Yes, so this is the same. Please note this. This will help us in the coming numericals. So if amplitudes are same, and it is the same thing, if A1 equals to A2, then you are supposed to write it AR, which is equals to 2A cos phi by 2. And if A1 not equals to A2, then you are supposed to write this one. If A1 not equals to A2, then you are getting AR, it's a resulting amplitude by this relation. And if A1 equals to A2, then you are going to have this resulting amplitude as a 2A cos phi by 2. I hope this is clear. Is it clear? Is it? Are you sure? Great. Ready for the question? Let's have a look. Let's say y1 is equals to 3 sine kx minus omega t, and y2 is equals to 4 cos kx minus omega t. Find out amplitude of superposed wave. How will we do this? So first we need to identify a phase difference of this two, and to identify the phase difference of this two, both would be in certain same trigonometric functions. This is on sine, this is on cos, so I need to convert any one of them, and to convert one of them, let's convert them to this sine. It's a 3 sine kx minus omega t, and this would be equals to 4 sine mind it, it's a cos. I have converted it to sine, to kx minus omega t plus pi by 2. Yes, we know that there is a phase difference of pi by 2 between the sine and cos, so I have added it. I hope this is clear. Now, the phase difference between this two, it's a pi by 2. My amplitude 1, it's a 3. Amplitude 2, it's a 4. What I want the AR. How will we do this? Let's have a look. To find out the AR, it's an A1 not equals to A2 case. So this is equals to A1 square plus A2 square plus 2A1 A2 cos of delta phi. So this is equals to under root of 3 square plus 4 square plus 2 into 3 into 4 into cos of 90 degree. When it is the case of the cos 90 degree, this is equals to 9 plus 16. This is root of 25, which will be the phi. This is the resulting amplitude. I hope this is clear. Now one more thing. Is it clear? Is it clear up till now? Yes. If suppose I have been asked, write down the relation of superposed wave for previous question. I hope this is clear. So when I superposed it, I must get this is AR sine kx minus of omega t plus, let's say, phi dash. So I get this AR, and that was the phi. This is equals to sine kx minus of omega t plus phi dash. Yes. Now if I want to find out the phi dash, how can I do this? Let's have a look. That my first relation, the y1, was 3 sine kx minus of omega t, and the second wave, which is equals to y2, which is 4 sine kx minus omega t plus pi by 2. This was the relations with the y1 and y2, and the phase difference between this two is the pi by 2. So if phase difference is pi by 2 and I need to find out the resulting wave, what I can do is that, look at this. This is having an angle of 0. It's basically 3 sine kx minus omega t plus 0 degree, and this is equals to kx minus omega t plus 90 degree. So whatever the wave which is having lower phase would be on the x-axis. So I have kept it like this, and this is of amplitude 3. Now the next wave, it is having an phase of pi by 2 with respect to this. So it is on this axis, it's 4 in magnitude. The resultant of this 2 is what we understand, it's a phi. So I want to measure this angle. Now we understood this is phi, this is 3. It is 53 degree. Yes. So the resulting wave will be phi sine kx minus omega t plus 53 degree. That's it. You did it. Great job. I hope this is clear. Is it clear? Is it? Are you sure? Great. One more question. One more. Let's have a look. The next question. Let's say y1 is equals to 6 sine kx minus omega t, and y2 it's a 6 sine kx minus omega t plus 2 pi by 3. Find out. Find out relation of superposed wave. This is required. So what we need to do is that this is the first function and this is the second function, If these two are the different functions and the phase difference, a phase difference between this is just 2 pi by 3, and we have been given the different amplitudes as well, that a1 is given which is equals to 6, even a2 is given which is equals to 6. So phase difference is 2 pi by 3 which is 120 degree, and the two amplitudes are given which is equals to 6 and 6. So what I need to do is, this is the case of the a1 equals to a2, and what I want this, it's yr is equals to ar sine kx minus omega t plus phi dash. So my requirement will be the two. First I need to find out the ar, and then I need to find out the phi dash. If I have done with this two, then I will get my answer. So let's first work on the ar, the resulting amplitude. So the resulting amplitude could be given as 2a cos phi by 2. If it is 2 into a into cos of phi by 2, this is simply 2 into 6 into cos of 60 degree. It's a 120 by 2. If it is a 120 by 2, this is equals to 2 into 6 into cos 60, which is equals to half, and this is 6 units. I hope this is clear. This is the resulting amplitude. This is the AR. Now I want the YR, and for that I need phase difference. So to find out the phase difference, give me a moment. Yes, let's say my y1 is 3 sine kx minus of omega t, and the second wave, it's a 4 sine kx minus omega t plus this is equals to 2 pi by 3, and this was not 3 and 4, this was the 6 and 6, my mistake. Yes, so what I need to do is, this is with phase difference 0, and if it is with phase difference 0, then this will be on the x-axis. This is 6 phase difference, it's a 2 pi by 3, which is 120 degree. It is something like this. As this both are equal in magnitude, the resulting vector would be on the angle bisector. So this is again 6, as I got this, and this is 60 degree. So the resulting amplitude could be given as, this is equals to 6 sine kx minus omega t plus 60 degree. 60 degree, it's a pi by 3. I hope this is clear. Have you got this? Have you? Are you sure? Are you? Now do you have any doubts? Is there anything? Is there? No? Great. So I hope the previous question was clear. Is it clear? Great. So basically, when we understand that we are on a superposition of waves, we are basically having 3 different applications of the superposition of waves. One of them, it's an intensity. The second one, it is the application of the standing waves, and the third one is the application of beats. So basically we play with these 3 applications when we discuss the superposition of waves, and we are going to discuss one by one. So let's discuss the first, intensity of a wave. So when we discuss about the intensity of a wave, we understood that intensity of any wave equals to, it's an energy divided by area into time. And when we say it's an energy by time, this is, and that should be equals to power divided by area. We can say so. I hope this is clear. Yes, great. So I understand that intensity is equals to energy divided by area into time, and if area is equals to 1 unit and same with time is equals to 1 unit, then intensity is numerically equal. Intensity is numerically equal to the energy of wave. Have you got this? Okay. Now when we say intensity is numerically equal to the energy of wave, what I was having energy when we were discussing with the SHMs, it was intensity, it was the total energy, and now in this case I am having this energy is equals to intensity. I can write this, it's an I is equals to K into A square. So a K could be given as M into omega square A square. Let's say M is constant and generally it does not changes. So what I can write, it's an I which is directly proportional to the omega square into A square, where omega is the angular frequency of wave and A, it is the amplitude of wave. So omega is the angular frequency and A is the amplitude of wave. I hope this is clear. Is it clear? Are you sure? Do you have any doubts? No? Great. So let's suppose the situation is that we are having one wave which is y1 is equals to a1 sine kx minus of omega t, or different wave which is a2 sine kx minus omega t plus phi. So the amplitudes are the different and the phase difference is the phi. So if I superpose this, it's a y1 plus y2. What I'm supposed to have is the AR sine kx minus of omega t plus phi dash. And if I'm going to have this, this is the YR, then how the amplitude, this AR could be written. So to get the AR, what we are supposed to do is this AR would be equals to root of A1 square plus A2 square plus 2A1 A2 cos of delta phi, and from this I can write this, it's a AR square which is equals to A1 square plus A2 square plus 2A1 A2 cos delta phi. Let's say that omega is the constant, that means I directly proportional to the A square. So if I try to replace this with the intensity, then this could be written as resulting intensity IR. This is equals to I1 plus I2 plus 2 root of I1 I2 into cos of delta phi. Please note this. This is the relation. This is the relation of resulting intensity, which is equals to I1 plus I2 plus 2 under root of I1 into under root of I2 into cos delta phi. I hope this is clear. Is it clear? Is it clear? Are you sure? Now, if I resultant is maximum, how this is possible? If I want that resulting intensity should be maximum, then this should be 1. It's a cos of delta phi should be 1, and if cos delta phi is equals to 1, then the phase difference between these two would be a 0 degree. This is one of the case. and if IR is minimum, if I want that this should be the minimum, how can we do this? Then to get this minimum, I should write it's a cos of delta phi should be equals to minus of 1. And if cos of delta phi is equals to minus of 1, that means the delta phi should be equals to 180 degree, which is pi. I hope this is clear. Is it? Great. So to get this solved, let's understood that if IR is maximum, so if IR is maximum, what I can have is the IR equals to I1 plus I2 plus 2 root of I1 root of I2, because cos delta phi equals to 1 here. So if cos delta phi is equals to 1 here, then what I can have is this is the resulting intensity, which is equals to I1 plus I2 plus 2 under root of I1 I2. So this could be written as root of I1 plus root of I2 whole square. I hope this is clear. And as I understood that this is I directly proportional to the A square, so what I can write, it's a root of I directly proportional to the A. So this could be written as A1 plus A2 whole square. This is the resulting intensity. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Do you understand this? Is it clear? Great. So this is the resulting intensity, which should be equals to IR, which is equals to A1 plus A2 whole square. I hope this is clear. And this is known as the constructive interference, and this is the IR max. This is the maximum resulting intensity what I can get. I hope this is clear. Is it clear? Is it clear? Okay, now what would be the situation? Let's try to understand this. Let's try to understood this with the help of a waveform. Let's suppose understand that this is my one of the wave, and this amplitude is the A1. Yes, and this is the Y versus T. Now let's say this is the A2, this is the second wave, and let's suppose if I'm going to superpose this two, then the resulting wave would be something like this. This is Y versus T, and this amplitude will be equals to the A1 plus A2. I hope this is clear. This is again A1 plus A2. I hope this is clear. Yes, this is the case of the constructive interference, that both amplitude are going to add with each other. This is what constructive interference is, and you are about to receive maximum possible intensity as well as maximum possible energy. So do you understand what I mean? Yes. Great. Now let's discuss if IR, its a resulting intensity, is minimum. If such is the case that resulting intensity is minimum, then what would be the situation? Then the IR should be equals to I1 plus I2 plus 2 root of I1 into I2 into minus of 1, because now cos of delta phi should be equals to minus of 1. So this could be given as this is the IR minimum. This is equals to root of I1 minus root of I2 whole square, and from this is the minimum IR, which is equals to A1 minus of A2 whole square. I hope this is clear. So this is the IR minimum which should be, and which is equals to A1 minus A2 whole square. This is known as the this is known as the destructive interferences. This is known as the destructive interference. This is the case of the IR minimum. I hope this is clear. Is it clear? Is it? So, any doubts in this? Is there anything? Is there anything? Any doubts? No? Great. So this is what we non and this is what we call as the destructive interference. I hope this is clear. Now, when we say destructive interference, the situation would be something like this. Because the phase difference is minus pi, its phase difference would be of pi, sorry. Let's say this one will be the A1, and suppose this is the A2 as the amplitude. The first amplitude was A1, and if I'm going to add this, as you can see, this A2 is bigger than the A1. So when I superpose this, what I get is something like this, and this amplitude is the A2 minus of A1. As this is dominating, it starts with the negative. If this was dominating, it starts with the positive. And this is example of destructive interference. Have you got this? Have you? Are you sure? Are you? So do you understand this completely? What is to be done, what is not to be done? Are you sure? Great. So I request you guys to please note down this and this for the destructive interference. Have you noted this? Have you? So give me a moment, I will give you the formulas of the constructive interference as well. This was destructive and this was constructive. Let's have a look. So please note down this. This is for the constructive interference. Have you noted it down? Have you? Great. So are you ready for the questions? Are you? Let's begin with the questions of the intensity. The question says that let's say y1 is equals to phi sine kx minus omega t, and y2 it is equals to 10 sine kx minus omega t. They said that find out I1 is to I2, I max is to I mean. So I need to find out these two things. I need to find out the I1 is to I2, and I need to find out the I max is to I mean. How will I do this? What is to be done? So what is to be done is this. I understand that I is directly proportional to the A square. Yes, the phase difference between these two is the 0, and I is directly proportional to the a square. So this is equals to I1 is to I2. Their amplitude, this is 5 square, which is 25. This is 10 square, which is 100. So this is equals to 1 is to 4. So this is the I1 is to I2. I hope this is clear. Is it clear? Is it any doubts? No? Great. Next, what I will need to find out is I max is to I min. So what I max is, it was a1 plus a2 whole square, and here this is dominating, that's why I'm writing it's an a2 minus of a1 whole square. So when I write a1 plus a2 whole square, this is 5 plus 10, which is 15 square, divide by 10 minus 5, this is equals to 5 square. So this is 225, divide by, this is 5 square, and when I say it's a 5 square, this is 25 nines are 225, it's 9 is to 1. This is I max is to I min. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Great. So let's move on for the next question. You are doing pretty well. Keep doing it and make it fast. Let's have a look. So let's suppose I have been given that y1 is the, this is equals to 10 sine 20 pi x minus 40 pi t, and y2 is equals to 5 sine 20 pi x minus of 40 pi t plus pi by 3. It's a 60 degree. I hope this is clear. So if they ask me find out resulting intensity if we superposed this two waves. So if we superpose this two waves, I need to find out the resulting intensity. How shall we do this? What is to be done to superpose this two? Yes. So what I need to write, it's an resulting intensity which is equals to I1 plus I2 plus 2 root of I1 I2 into cos of delta phi. Yes. So this I1, and we understand that I is directly proportional to the a square. So this is a, it's a 10, it's a square, it's a 100 plus 25 plus 2 to root of 10 root of phi into cos delta phi, the phase difference, it's a pi by 3, which is 60 degrees. So this is simply the root 3 by 2. So this 2 has gone, and this is 100 plus 25, this is 125 plus this is under root 10 under root 5 under root 3, it's a 5 3s are 15 root of 150. This is intensity, it's a watt per meter square. I hope this is clear. Is it? Is it clear? Are you sure? Great. Ready for the next question? Ready? Let's have a look. The next question. Let's suppose the question is that y1 is equals to 10 sine 20 pi x minus 40 pi t, and y2 it is equals to, let's say, 2 sine 40 pi x minus 8080 pi t. Find out ratio of intensity. This is the requirement. How will we do this? What is to be done? We need to find out the ratio of the intensity. What can be done and how this can be done? So this is y1, which is equals to 10 sine 20 pi x minus 40 pi t, and this is y2, which is equals to 2 sine 40 pi x minus of 80 pi t, and we need to find out the ratio of the intensity. So how will we do this? So look at this. This is 40 pi t, this is 80 pi t. That means both are having different omega angular frequency. So my intensity would be an a square into omega square for this time. So let's take a ratio of this. It's an I1, which is equals to a1 square into omega 1 square, divide by I2, which is equals to a2 square into omega 2 square. So this is equals to a1 square, it's 100, a2 square, it's a 4, multiplied by omega 1 square, it's a 40 pi whole square, and this is equals to 80 pi whole square. If this is the situation, this is equals to I1 is to I2. This is 100 by 4, which is 25, multiplied by this is 40 pi, this is 80 pi, 42s are 80 pi, and this is equals to 1 is to 4. So this will be the 25 is to 4. This will be the resulting intensity of a wave. I hope this is clear. Is it clear? Is it? So do you have any doubts up till now in this intensity? Are you sure? Any doubts? Any? Is there anything? No? Is there anything? No? Great. So let's wind up this session over here. This was all about the superposition of wave and the intensity of a wave. Basically, superposition is the structure with which it's a principle with which we are going to discuss three of the applications, and this was just the first application. Which is the intensity of which is it is the intensity. In the next classes we are going to discuss about the superposition of waves and the beats of a wave. So please revise this very carefully, and this will help us. Basically, this principle of superposition and its formula will help us to get next applications to be done very efficiently. Thank you. Have a good day. Take care. Bye bye.